Today we're going to be talking about vectors. And we use vectors a lot actually in physics, but it's part of geometry. And this is kind of just a brief introduction to vectors. Okay, vectors have a magnitude and direction. I used to teach with something that said that vectors are kind of like rays. Okay, just they have a magnitude, which is a specific length. Okay, so they have a magnitude, and we write that with bars around it. Magnitude of vector AB. And then they have a direction, so coming up from 0, so coming up from this positive x-axis, they're going to have some direction. That's a Greek letter called theta. That's often what we use for an angle in mathematics. Okay, so they have a magnitude, a length, and a direction. And A, where that tail is, that is called the initial point. And then here B, that is the terminal point. Okay, so the ending point. So you have the initial point A and terminal point B. Using a ruler and protractor, draw each vector, use a scale on it, included a scale on the diagram. So we have vector S. It might be kind of hard to see that. That's a little S with a little arrow over the top. That's our symbol for vector. Is 80 units long and 24 degrees west of north. Now I have these amazing directions of use a ruler and a protractor and use a scale. And I'm going to go exactly against my diagram. Okay. I just want you guys to be able to sketch it. Okay. 24 degrees west of north. So north is here. I go 24 degrees to the west of that, and that is 80 units long. I kind of just am worried about you guys getting that in the correct direction. Okay, adding and subtracting vectors. I'm going to use the same terminology that Mr. Jeans, our physics teacher, uses, and that is the tip to tail method. Okay, so if we're trying to add vector u plus vector v, okay, so I start at the initial point of u, and I go through vector u. And then vector v, so this initial point, that is the tail, and then up here is the tip. And then the tail starts here of our next vector. And the resultant vector, or the sum, is from the tail to the tip of your last vector. Okay? Say, for example, and I'll use the vector that I have there. Say u is going in that direction. Negative u is the same angle, same length, just opposite direction. So here we want to find, copy the vectors, and find a minus b. So we start here. You can start anywhere in your plane. Vector A is that length. Now B is going in this direction, going towards the right, I'll say. Negative B is going the same direction, just the opposite way. So this resultant vector is A minus B. And we put our little vector symbol over it. Okay, writing vectors in component form. So we write a vector what it means by writing something in component form is we have an x direction, comma, y direction. And so to find the length of this vector, you have to find the length of that, which is x2 minus x1. So the length of this is x2 minus x1. And this is your a component, your x direction. And then you have your y direction, which is y2 minus y1. And that's your b direction. Magnitude of a vector. Hey, that looks familiar. I'm recording this in right before Christmas break of 2021, and my students are really struggling with the distance formula. That's the distance formula. That's all that is. Okay, so I have my distance formula there. Or if you have A and B, it's the Pythagorean theorem, because this is a right triangle. So it's just redoing all the stuff that we've been doing, just now a nice application of it. Okay, find the component form and magnitude of AB. Okay, so you always start at A, you always start at this point. That's always your x1, y1. And the terminal point is always your x2, y2. Okay, so component form. We have -5 minus a -1. And then I have -1 minus a -4. And that turns into -4, 3. And then since I have that, to find its magnitude, since that's my A, that's my B, and again, highlighting that this is the X direction, I go 4 to the left. Since I'm negative, I'm going to the left. And then 3 up. We do the square root of -4 squared plus 3 squared. That's the square root of 16 plus 9, the square root of 25, which equals 5. Okay, number 4. Find the magnitude and direction of this vector. Okay, so the vector could be put anywhere in the plane. I am going to start our vector at 0, 0. And this is my x direction. So I go 7 to the left. And I go 5 up, 5 up. That's my y. So from this terminal point, from this initial point, I go 7 to the left, 5 up. That's my terminal point. So that's what my vector looks like. Okay, so the magnitude, that's the easy part. I promise you that's the easy part. So we have a 7, we have a 5. So that magnitude is the square root of 7 squared plus 5 squared, which is the square root of 74. The direction is a little bit more challenging. The direction comes from 0 rotating this way. So it comes from this positive x-axis rotating counterclockwise. And that has to deal with a bunch of trigonometry that, quite honestly, I haven't taught you yet. But I want you to see at least one of these problems. So rotating from 0 to there. So that's the theta I'm looking for. Let's look at this right triangle here. Let's look at this right triangle. 5, 7, and I'm trying to find that angle there. So, past 2 days we've been doing SOHCAHTOA. So, tangent of that angle, I'm going to call it A, is 5/7. Ignore the fact, technically that 7 is negative. Ignore the negative piece. Because of how inverses work and a whole bunch of math that you guys don't know yet, just don't worry about it. And just ignore any negatives when you're trying to find the angle. So I write that, I find that, and the inverse tangent of 5 divided by 7, that is 35.54. So that's what this angle is here. That angle there is 35.54. I need to find this angle theta. So theta plus that 35.54 add up to 180. So I do 180 minus my 35.54. And I get, I don't know why I wanted to change colors, 144.46. Okay. Don't super stress about that problem. I wanted you guys to experience that because you're going to be doing this next year in Algebra 2 Trig. Okay, adding vectors. Oh, adding vectors, it's so easy. All you do is add the like components. Add the x components together. Add the y components together. Same thing with vector subtraction. Multiplying by a scalar. Let me get a different color. Scalar. That's just some constant outside that I bring in and I multiply to everything. So don't overthink this, people. Okay? Okay. So, find each of the following, check your answer graphically. So I want to show you guys that it's actually really, really, really easy. So x plus y. So I add my x components. So I have -1 plus 3. I add the y components. And so there I have a 2 and a 5. I don't like how that looks. Okay, so let's show you how this works graphically. So x, I'm going to start x at 0, 0. I go 1 to the left and 4 up. So that's vector x. Vector y goes 3 to the left. I'm sorry, 3 to the right. It's a positive 3. So I go 1, 2, 3, up 1. So that's y. What's my resultant? My resultant coming from the origin up there is x plus y. What are the coordinates of this point? 2, 5. Okay, so that's all you're doing. Okay, on this one, I need to do z minus x. Okay, so now all I'm doing is subtract it. It's all I'm doing here, people. So you take and you have z, -2 minus a -1, -4 minus 4. So now my resultant is -1, -8. So x is -1, +4. Oh, well, my grid doesn't make sense. Oh, I'm sorry. I have to start with z. Haha, I have to start with z. So I go -2, down 4. 1, 2, 3, 4. So again, that's z. Now I need to do the negative of x. Actually, I'm going to erase that. I apologize. I mixed up my colors. So I have a -2. 1, 2, 3, 4. X. Okay, instead of going, since I have to do negative x, that's just the opposite. So that's 1, -4. So I go left 1, down 4. So that's -x. What's my resultant? My resultant is that vector, and that's -1, -8. Okay, the last one, or the last one of these like addition kind. I have to do 2y, so 2 times y, multiplying by a scalar, well, that's going to be a 6, 2. I just take it and multiply each component by what the scalar is, plus z. And I'll underline z in red. So I have 2y Okay, so I have 2y, so I have a 6 plus a z. I have 2y, which is 2, plus a -4. Now we have to do 6 minus 2, that's a 4. 2 minus 4 is a -2. So let me show you on a graph what 2y looks like. So for y, I'm going to start at the origin again. And I go 2 over 1 up. So that's 1y. 2y, I start from this point and I go the correct distance, Mrs. Marnell. I go 3 over 1 up. So that's 1y. Now with 2y is I go 3 more over and 1 more up. So that's another y. Then my z, starting at the tail here, or I'm sorry, the tip here, for z, I go down 2, I go left 2 and down 4. So this is vector z. So what's my resultant? +4, 1, 2, 3, 4, down 2. Okay, our last example. You have to find 3a minus b. So let's find 3a. 3 times 2 is a 6. 3 times a -1 is a 3. Okay, so then I have to do, and b is (3a), 6, b I will do in red, minus 5, 3b 3a, I'm sorry, is negative 3 minus a negative 3. So what's my result? My result is a 1, 0. So that's my video on vectors. Thank you for watching.